We are at chapter number 3, where we are learning how we make conceptual design or conceptual schema. And we saw that our conceptual schema is basically description of our data requirements, yani what are different data items which the company for which you are making the database, what are the data items they want to store into database, and what are some other conditions. If the data items which need to be stored, they are related to each other, we should find their relationships. Here you can see the different steps through which we can make our conceptual design. And you know that conceptual design is our phase number 1, and our phase number 2 is our logical design, and our phase number 3 is our physical design. So in our first phase, conceptual design, we design our data model. To design our data model, we identify entities, we identify association among entities, we identify the association or relationship or any other constraints. And we saw how do we identify entities. Basically, these are all the nouns in the description. For example, here you see the description of company database. This description, how do you get that? Basically, you talk to the company employees, you interview them, you talk to the company representatives, you look at their reports, at their forms. From there, all the data requirements are collected, and those requirements are written down. Something like that. This is the description of their requirements, their data requirements. So from this description, you will identify all the nouns, all asma. In Arabic, you call it asma or ism. You identify all the nouns, and the nouns can be either entities or their attributes. If a noun can exist independent of other nouns, then it is entity. If it cannot exist without other entities, then it is the attribute of entity. We have seen some examples last time. Example of departments, which is an entity. Example of employee, another entity. Dependents, another entity. And then we learned how do we represent entities, and we learned that we represent them with a rectangle. This is the symbol to represent our entity. And then we saw how do we represent the attributes. We use oval symbols, something like that, to represent attributes of entity. Then we saw different types of attributes, including simple or composite, single valued or multi-valued, or derived attributes. Then we saw if an attribute is multi-valued, we represent it with double oval. As normal, all single valued attributes are represented by single oval, and multi-valued, they are represented by double oval. Double oval means more than one values. It can be 2, it can be 3, or even more. If our attribute is derived, we represent it with a dotted oval. Then we saw the composite attribute, which is basically made up of more than one attributes. Then we saw how do we draw attributes together with entity. Entity is represented by rectangle, attribute is represented by oval, and if attribute is key, yani it has a unique value always, then we represent it with an underline. We underline it. It means that this is a key attribute, which means that its value is always unique. Then we saw the concepts of super keys, candidate keys, primary key, and alternate key. We saw it with the help of examples. Then we saw how do we represent them. This was a simple example of car, entity car, then its attributes. And we saw that registration and vehicle ID, both of these are underlined. It means their values are always unique. Color is a double oval. It means its value is multi-valued. It can be 1 or 2 or 3, depending upon the values, depending upon different cars. It can be 1 or more. And you see that registration is a composite attribute, yani it has further 2 attributes, state as well as number, which are part of registration. Similarly, we saw more examples of our example company database. We saw how do we represent department with 2 key attributes. Location is multi-valued. Manager and manager start date, these are single valued attributes. Second example, we saw project. It has 2 key attributes, name and number. Its location and controlling department, these are single valued attributes. Similarly, employee and dependent, we saw them. And together, we saw 4 examples. Example number 1, 2, 3, and 4. This is what we saw so far in our last lecture. And today we are beginning it from here, from this slide onwards. The very first concept for today is the difference between strong and weak entities. What is weak entity? First of all, we will start with weak entity. A weak entity is an entity for which there is no primary key in the table. If there is no primary key in the table, that all the entities in that table will be called weak entities. However, if in a table there is some entities and one of them is strong and one of them is a primary key or key attribute, then those entities are called strong entities. Let me show you with the help of examples. For example, we talk about hotel and its rooms. If we just talk about rooms without the hotel, the meanings are not clear. I say room number 7. You will ask where? Room number 7 where? I have to tell you the name of the building, or I have to tell you the name of the hotel. Maybe hotel, maybe some other college or etc. So when I call room number, only room number is, the story is not complete. It does not convey all the meanings. I must mention the building or the hotel name. Similarly, so we say that room is a weak entity and hotel is a strong entity. So to describe room, we must have the hotel name or hotel ID, something which describes the hotel. So room is weak and hotel is the strong entity. Second example, if we talk about section, only section ID, for example, the section ID is KZ1. So if I say you go to section KZ1, you will say, doctor, which course? Definitely section, only section is not enough. Section is described by a course. So only section, it's a weak entity, and course, of course, it is strong entity because it can describe itself. If I say you that one student has registered CPIS 250, you understand it. This is okay, fine. So he has registered this course. Third example, if I say that Ali is a son, is this complete? No, the meaning is not complete. You will always ask that he is a son of whom. So I have to tell you the parent. So only child, if I say child of, then I have to definitely say his parent name. So child is weak entity and parent is strong entity because it can exist by itself. How do we represent weak entities? We represent it with a double rectangle symbol. If you see a double rectangle, you will come to know that this is a weak entity. So it means for that entity, we need some other entity to describe it, to make the meanings complete. Usually when we use foreign key, that foreign key means in one table it is primary, and in second table it is called foreign. So once again, key is the same. Key will be the same, for example, staff ID or student ID. We use student ID in one table as primary key. In other table, we will copy it, and in that table, it will be called foreign key because initially it does not belong to that table. All other students, please hold on because he just asked some concepts which I have not explained. Let me answer his. I will show you in the coming slides how do we do that, but let me answer his question. For example, let's talk about me. My original country is Pakistan. Over there, when I'm over there, I'm national to that country. But when I come here in Saudi Arabia, same key. Same person in Pakistan is okay, simple, normal, or you can call, if you have my ID there, it is primary key. When I come here, then my reference here will be foreign. I'm the same person. My reference in my country, Pakistan, will be primary key, and my reference here will be foreign key. So same thing when it copies into another table just to make a link. That is foreign key. I will give you more example. Hold on for some slides. I'm going to show you inshallah this. Okay, first see this slide. Here we have, remember our company database example. There we had a client, and for client, this is an entity. Client is described by client number. It is described by name. In name, we have first name, we have last name, and its telephone number. Then client has its preferences. Again, preferences is another entity because it is a noun, and we identify that all nouns, they will be converted to either entities or their attributes. So its attributes are preference type and maximum rent. Preferences, if we just talk about preferences, we don't talk about client, just talk about preferences. Of course, you will be asking preferences of what? Preferences about what? Preferences of whom? So only preference is not complete story. So we have to tell that preferences about what or preferences from whom. So here we have preferences from a client. So preference cannot exist independently because if we just talk about preference, then this story is not complete. We have to have something else which describes something about preference. So we link preference with the client, that preferences of the client. Now the story is complete. Our preference entity is the weak entity because only when it exists independently, that's not possible, that's not complete. Client, only client, this data can exist independently. When I just say client number, client name, client telephone, you understand that I am referring to a person. Okay, it can exist independently. That's why we call it strong entity. Let's consider another example. We are talking about that you go to a superstore or somewhere to a store, you buy something. After you pay the cash, you get the invoice. So these are data for two invoices. The first invoice is 5092. The invoice date is 12/11/2013. Employee person who made this invoice, his name is Ahmad, and the total amount for the invoice was 230. Okay, so of course in that invoice you would have sold something. Those products that you have sold are listed in a second table. I have to exit and do it again. Okay, so another table describes that what were the products which were sold? Product number 1121, product name is XYZ, and quantity is 1, unit price is 90. Then 7812, product ID, product name ABC, and these are the products which are sold. Quantity 2, unit price is this. Similarly, other data items. These items were sold. If you just look at these items, how do we describe these items? Which attribute identifies each row? These items definitely were sold in some invoice. So do we have something here, that something like invoice in this table? Nothing, we don't have. There is no such attribute which defines each of the products sold. Then what do? We need an attribute here which can define each product ID sold. So what do? Remember, this is table number 1, this is table number 2. So in table number 2, we have to copy something from table number 1 and link these two tables together. This was the invoice number 1, this is the invoice number 2. For in each of these invoices, some items were sold. So we have to tell here that this product was sold in invoice number first or second, first or second, first or second. For each record, we have to tell them. So what do? We copy this invoice number from our parent table into this table. 5092, 5092, 5092. Yani it means the first two items, they go to invoice number 5092. And the last three items, they all have their product invoice ID 5093. So it means these three items belong to invoice 5093, the second invoice here. So this table, that was product sold, it cannot exist independent of the invoice table. So this is a weak entity, this is a weak table, weak entity, this is strong entity. So we copy something when we are creating databases into Oracle or any other software like that. We copy something from the strong entity, the parent entity, into the dependent entity or the weak entity. This invoice number, which column we are copying, which attribute we are copying, we should copy the primary key attribute. We should copy only the primary key attribute. So primary key is copied here. In this table, the invoice number is called primary key. When you copy it into another table, in this table, green table, it is called foreign key. Okay, alhamdulillah. See another example. Now we are talking about two different tables. The first table is courses. Course number CPIS 250. The course name is databases. Number of credit hours 3. Location is this building. Similarly, another course, the name of the course, credit hours, and location. For each of the course, sections were created. The first section is this one, instructor name is this one, location is this, etc., etc. You look at that, your sections, you know that this is weak entity because section has to be of some course. So there must be some course with which we will link the section. How do we link it? We copy the primary key column from our parent table or strong entity, which is the course. We copy into our second table, which is the course ID. When you copy it here, it becomes the foreign key. Course number here is primary key. Into the other table, it is called foreign key. Table section, it was weak table, it was weak entity, and course, it was strong because it can exist other than without section, but section cannot exist without a course, so it is weak, and it is strong, or the parent, so we copy something. The related parent or related strong entity, we copy primary key into the weaker key. In some situations, only in some situations, which are not normal cases, we do need to copy two foreign keys. That is possible. When I will teach you, inshallah, hopefully during SQL, we will see some cases like that, where we need to make two foreign keys. Technically, it is possible. Technically, it is possible. If we are taking some values from any other table, we must link them so that if some values are deleted in one table, it should automatically be deleted from the other table. If the values are changed in one table, it should automatically be changed in another table. So if something is repeated in more than one table, we should link them all together. So actually linking is called foreign key. Here we are linking this course number to its parent table. This course number is coming from course table, this course number. This is coming from here, this table. So we must link it. So linking it back to the parent is called foreign key. So many times, not many times, sometimes we need to link more than one. For example, here the instructor name, you can understand that there will be another table. Its name will be instructors, which will have all the data of instructor. So these values should come from the table instructor. So we will also link this column, this attribute, to its parent table, which is instructor table. So then this table, section table, it will have two foreign keys. One, course number. Second, instructor name. So it will have two foreign keys. Similarly, if you have a separate table for the location, then we will also link this column to that table. Then it will have three foreign keys. So next step is defining the relationships. And how do we define the relationship? A relationship basically connects two entities. For example, see in this table, in this slide, you see one entity student, second entity course. Is there any relationship between entity student and entity course? Yes, there is a relationship. What is the relationship between these two entities? A student registers a course. So the relationship name is registers. So we connect in our picture, in our diagram, we will connect entity student with the entity course. We connect them together, and the connection is through this shape, which is called a diamond shape. So diamond shape represents the relationship between two entities, student and course. Similarly, in English, a second relationship, see here, employee works on a project. Employee works on a project. So employee is an entity, project is an entity. They are related together with works on. So name of the relationship is works on. So employee, entity, project, entity, we connect them together through their relationship, which is works on, and relationship is always mentioned in a diamond. So diamond means this is a relationship. Okay, so it was simple. Next is degree of relationship. Guys, let me explain this concept to you for once and for all. Degree means you count the number. Degree, wherever it comes, it means you count the number. So degree of relationship means you count the number of entities in the relationship. How many entities are here in this relationship? 2. So the degree of this relationship will be 2. And in this relationship, how many entities are here? 2. So the degree again will be 2. If the degree is 2, it is called, usually it is called binary. If degree is 3, then it is called ternary. Similarly, you can say 2, 3, 4, or you can say binary, ternary, etc., etc. Okay. You can see here, for this relationship, the degree is 2 or binary. And here, A supplier supplies some parts for a project. A supplier supplies part X or part Y for a project. So three entities, supplier, project, and part, they are related to each other, and this is the diamond linking them together. So this is a ternary relationship. Ternary means three. Okay, look at this picture. This will help you in making your in writing your degrees. So this picture is called semantic picture or semantic net that explains the relationship between two entities. This is just for your understanding. Semantic means the meanings. When you understand the meanings, it's not a part of your ER diagram, but it will be helpful for you to understand. First, the entity is branch. Second, entity is staff. So branch and staff, they have the relationship. Of course, they are related to each other, and we say the name of the relationship is has. Branch has staff. For example, the branch B003, it has a staff whose ID is SG37 and SG14. So you see branch 003 is related to SG37. It has another relation with SG14. This R1, R2, R3, these are the relations or relationships. So you can see B003, it has two employees. B007 branch, it has only one employee according to this picture, SA9. Okay. This has, it is the name or name of the relationship or name of the role. Role or relationship same. Sorry, the role, I'm just going to explain you something about role name with the help of example. For example, look at this ER diagram. Staff is an entity, branch is an entity, and they are related to each other in two different ways. First way is branch has staff, and second relationship is that one of the staff member is the manager of the branch. So these are two different relationships. First relationship is branch has a staff, and second relationship is one of the staff member manages the branch. So that staff member is manager. He manages one branch, so we call that branch office. So manager is the role name, and branch office, you can also call it the role name, that manager manages a branch office. Similarly, a branch office or a branch, same thing, it's the same thing. A branch has members or staff. So this is the second relationship. The role name here is staff, and role number here is branch office. To understand it, see these two examples. This is example number 1 and this is example number 2. First example, I say Ali is father of Sabir. If I say this, Ali is father of Sabir, or I say Sabir is son of Ali, this means the same thing. It just, I go from left to right or right to left, only the direction is changed, the relationship is the same. So this is one relationship. Second, if I say Safiya is Ali's wife, and then I say Safiya is Ali's cousin, are these two relationships or one? Of course, two. Yeah. If I say here Safiya is Ali's wife, or I say Ali is husband of Safiya, this is one relationship. So you can easily say, you can easily find out that these are one relationship or two. Only direction does not change the number of relationships. Okay, now we see that relationships can be expressed, can be more than one people can be involved in the relationship. So on the basis of that, we can define that from both of the parties how many entities or how many attributes are linked together. To understand this, we are going to find the cardinality of relationship. The cardinality of relationship means the number of occurrences in one entity which are associated with number of occurrences in another. For example, see here, this is one entity, employee, and one entity, second entity, department. This is the relationship. R1, R2, R3 are the relationship. Name of the relationship is manages. Name of this entity is employee. Name of this entity is department. Look here. One occurrence of this employee, which is E3, it is linked to one occurrence of department D1. Similarly, another occurrence E5 is related to one occurrence of D3. E6 is related to D2. So we see that one entity, one occurrence of this entity is related to exactly one occurrence of this entity. So one from here and one from here. This is called one-to-one relationship. If one occurrence from one entity is related to exactly one occurrence of another entity, this is called one-to-one. From that, can you tell me what do we mean by one-to-many? Yes, mashallah. One branch has many employees. If we have something like that, it will be called one-to-many. See here, employee, entity, department, entity, and see here the relationships. One department is linked, is related to many employees. D1 is related to E1 and E3 and E6. Similarly, D2 is related to E2 and E4. So one from here and more than one from here. More than one means it can be two. In some cases it can be two, in some cases it is three, some cases it can be four. So it means more than one. More than one can be any number. That we will represent that with M. M for many. Okay, so that was 1 to M. Question. If I say 1 to M and sometimes I say M to 1, is this the same thing or different things? 1 to M, okay, 1 to M and M to 1 is same thing. Excellent, guys, excellent. But for us, it is the same thing. We say 1 to M or we say M to M. Mathematically, these are different. Mathematically, these are different. 1 ratio M and M ratio 1 are different. But to express the relationship, we say 1 to M. It means, see here, in this relationship, M is here and 1 is here. Okay, M is here, 1 is here, so it is M to 1, but we say it 1 to M. Okay, so for us, it means we take one occurrence from one entity and many occurrences from second. So you can count one, this one, and this is second. If you say this is one, then employee will be second. If employee is the first, department will be second. In our countries, we start from the right side. So this is the first, that will be second. Other people, they start from the left. So for them, this is the first and this is second. But the relationship, when we will say, we will always say 1 to M. That was something funny, just to make you smile. Anyway, similarly, if there are many to many, many means more than one. So more than one from here, more than one from here. One employee can work on more than one project, and one project, it has many employees working here. So more than one is many, many employee, many project, many. If there are many to many, so what should we say? M to M? No, we don't say M to M. We say M to N. Okay, so it means many to many, because M to M means both are exactly same. If we write M to M, it means first is M, second is also exactly same M. So it does not have to be 2 to 2, it does not have to be 3 to 3 or 4 to 4. It can be any number on the first occurrence and any number on the second occurrence. So we say that M to N. See here, project 1, how many employees it has? 2. Employee 2 is working on how many projects? 2 projects. Employee 3 is working on how many projects? 3. And our project 3, how many candidates, how many employees does it have? 2 employees. See here, 2 employees. So sometimes it is 1, sometimes it is 2, sometimes it is 3. If it counts 1 and more, we say many. Okay, there is a mistake here, guys. Can anybody tell me what is the mistake in this picture? This ER diagram, it shows the relationship between entity private owner and entity property for rent. The relationship name is owns. Private owner owns a property. Where is the mistake? So diamond shape was missing. Now I am creating the diamond shape here. Okay. So this is the diamond shape. Now it's fine. Okay. Otherwise it was not correct. Inside the diamond it should be empty, but just for the sake of correction, I just inserted a diamond. Ternary relationship, we already saw that. Okay, after ternary, the relationship that involves 4 entities, this is called quaternary. Qua means 4. So quaternary, it involves 4 entities. Okay, so this is our initial design of our ER diagram for our example of company database. In company database, this is entity department, entity project, entity employee, entity dependent. Next is we have to, so what are the 3 steps of making conceptual schema? Can anybody tell me the 3 steps for making conceptual schema? This chapter is all about conceptual schema or conceptual model. So we have now made entities, we have now made attributes, and now we are going to make the relationships in our initial model. So let's do that. This is our entities, these are the attributes. Entity, attributes, entity, attributes, entity, attributes. We have to link them together. Yani relationship, yani associations. So the first relationship between employee and department is works for. An employee works for a department. Similarly, another relationship between employee and department is that one employee manages one department, and one employee will be the manager. Then another relationship between department and project is that a department controls a project. Where do we get these relationships from? Simple answer. We must have the description of our data requirements. You know, at the start of today's chapter, I repeated it for you, that the whole process starts from, first of all, we must have our data requirements. How do we get data requirements? We talk to the employees, we talk to the company managers, we talk to the users, we see their reports, we see their forms. From there, we get our data requirements for our database system. Then we write them everything. From that written description, we identify entities, then we identify attributes, and then we identify the relationships. We do not make it from our brain. No, we do not make it from our brain. we must have a written description of our case, and from our written description, we extract these things from there. Okay, so that means the person who writes all the description for us, he is very, very important person. He should not make any mistake. He should write everything, because then after our all next steps are taken from his description. If his description misses something, of course we will miss it in our database. We do not make anything from our own brain. We do everything according to the written description. So the person who writes this description, he is called database analyst, because he visits the company, he asks them what are your requirements, he talks to them, he sees their existing forms and reports and everything. Then he writes a description for us. That description is called our data requirements. From our data requirements, we identify all nouns, all isma, kullu isma. Those are either our entities or attributes. Then, second, we look for all verbs. All verbs, yani all fail. Fa, ain, lam, fail. Kullun fail. All the fail, they are our relationships. So the nouns will be entities and or attributes, and all the verbs, they will be the relationship between entities. Can anybody help me, Rayan or Abdul or Ahmad Ali? Can you say this in Arabic, please? I repeat in English and you will say it in Arabic for our students so that they can understand, because it's very important for us. First thing, we do not make anything from our brain. We get all the specification from the written data description, data requirement. And in the data requirement, all the nouns will be our entities or attributes, and all the verbs will be our relationships. So this is time for us to extract the relationship. How do we identify the relationship? We identify the verbs. So those verbs will be our relationship. So the first relationship is works for, manages, controls, works on. So employee and project, how they are related to each other. They are an employee works on a project. Similarly, supervision. I will explain this. This is a very interesting relationship. Supervision is a relationship of an employee with an employee. Yani recursive relationship. Yani relationship to itself again. So this is very interesting. It is coming in the next slides. Inshallah, I will explain this to you there. And dependent of, again, an employee, it has some dependent, or some person is a dependent of an employee. We will see. It's time for us to express all these relationships in our initial model. This was our initial model or initial design, where we had our entities, we had their attributes, and we had our project employee and their attributes. Now it's time to link them. Let's link them. This is our ER diagram of all those connections. You see here, employee, it has two relationships with the department. First, employee works for a department. Second relationship is employee, one of the employee manages the department. Second, employee, it has dependents. So it has dependents. So the relationship between employee and dependent is dependent of. And you see here double diamond. A double diamond means it's a weak relationship, because on one side we have a weak entity. Weak entity is represented by a double rectangle. Then employee, it has a relationship with project. That relationship we saw already here. Works for, employee works for a project. So employee works for or works on a project. Then the relationship between project and department. A department controls a project. Yes. And then another relationship is we have some employees. One of the employee is basically supervising other employees. So you see here, this entity, it has a relationship again back to it, because one of the employees here, there will be all employees here. So one of the employees supervises other employees. So if we have a relationship back to itself, the same entity, this relationship is called recursive relationship. Okay, besides that, an interesting thing here is you see a department and you see here a dotted oval. What is dotted oval? Dotted oval means number of employees. Yani you are counting how many employees we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we have 11 employees. Since this is a counting, we do not store it in the table, because at some time we have 11 employees. After 1 month, maybe there are 10, or maybe there are 8, or maybe there are 15. So this number is changing. Whenever there is some computation or some counting, we do not store that information into database, because it will always be changing. And I told you in our last class, this attribute is called derived attribute. We do not store derived attribute. We calculate it on the runtime. So it is represented with a dotted oval. It means it is the derived attribute. And what else? What else? This is another something. Yeah, two more things. One, I will leave it for later. That is works on. This is a relation. This is a relationship between employee and project. But this relationship also has an attribute. Oh wow, that's great. That is new thing for us that we are seeing here. We will discuss it sometime later. That a relationship may have some attributes, because an employee works on a project and how many hours it works on a project. That is that sometimes we also need to store this information. So it is possible to have attributes of a relationship. So this is something new which we learned in this figure. And you see here another um, relationship manages. It has also an attribute starting date, yani starting date of the manager. And last thing which is left in this picture is these numbers which are written in brackets. 0 to n, 0, 1, 1, n, 0, 1, 1, 1. This I'm going to explain inshallah in our next slides. This is a recursive relationship. Staff members, one of the employee, it supervises other staff members. This is called recursive relationship, already explained to you. Okay. These numbers which you are seeing in the picture, in the diagram, these are called multiplicity. Okay. These numbers are called multiplicity. Yani we are telling how many items, how many elements from one entity have relationship with the occurrences in the second entity. See this picture. This is first entity, staff. This is second entity, branch. How many occurrences from staff, they have relationship with how many occurrences of branch. From this picture, we see 1 to 1. From this picture, we see 1 to 1. Okay. This is the semantic picture. We have to write the relationship from our description. Our description tells us that relationship. We will see what it is, but we have to write that relationship. So the first relationship between staff and branch, let's read it from staff to branch. A member of staff can manage how many branches? 0 or 1 branch, because not all the employees are the managers. Some of the employees will be the simple employees, while others will be managers. So we can say that a member of the staff or one a member of the employees can manage 1 or 0 branch. He cannot manage more than 1, but he can manage 0 because some of the employees will not be the managers. Now let's read it from branch to staff. From branch to staff, we can say each branch is managed by 1 staff member. Each branch is managed by 1 staff member. This kind of description, we should start from left to right, yani from staff to branch, then from branch to staff, both ways. We have to write it from both ways. Each description should start from A or each. The description should start from A or each. Like here, we saw a member of staff can manage 0 or 1 branch. Here it starts, each branch is managed by 1 or 1 staff member. Okay, so these are the 2 tips that I gave to you. We are going to practice it in more examples coming in next slides. So let's see it. First of all, this type which mentions the number, it is called a constraint, or it is called a structural constraint. These are the numbers here that I am going to explain to you: 0, 1, 0n, 1 to n, 0, 1, 1, 1, and it is on both sides of the relationship. 1 on the left side, 1 on the right side. How do we do that? First of all, the name of this constraint, structural constraint, is multiplicity. How do we write multiplicity? I am explaining this to you. First of all, we should make a semantic net, and then we should write the description of the relationship from left to right, yani from staff to branch, and then from branch to staff. This description should start with A or each. You write it A, you write it each, it depends upon your language, doesn't matter. Then we will convert it to our ER diagram. This is our picture from the last slide. This is called semantic representation. We have to make an ER diagram. How do we make an ER diagram? What is this entity name? Staff. What is this entity name? Branch. So we make staff, this is staff, and this is branch, we make a branch. This description that you wrote here, that was from staff to branch, this will come on the right side, and the right side description will go to the left side. Okay, so the right side description, it says 0 or 1, so it is 0 or 1. Okay, and the left side description, it is say 1 member, exactly 1 member. It cannot be 0, it cannot be more than 1. So minimum is 1, maximum is 1. So these are 2 numbers, 1, 1. It can be the numbers given, or it can be minimum or maximum. Okay, so once again, the description which is written on the right goes to the left, and description written on the left goes to the right. Then it is converted to the numbers. These 2 numbers are called multiplicity. So multiplicity is 1 to 1, and from here 0 and 1. Together, these 2 numbers are called multiplicity. Remember, it should be a diamond here. So this is our ER diagram. If I give you this question in exam, and then I ask you write the multiplicity, you will write 0 dot dot 1 and 0 dot dot star. You write both these numbers. Both of these numbers are multiplicity of the relationship. So multiplicity has 2 values, left side values and right side values. Yes, in one value, this 0 and 1, this is one notation. I'm explaining this in the coming slides, that you can write it with these numbers, what is given, or you can write it with a comma. Inside the comma, it will be minimum and maximum. Stay with me. I'm going to explain this to you. Wait for a little bit. I will explain this minimum and maximum to you. Second example, we just saw the first example, staff and branch. Now we are going to see the second example, which is our staff and property for rent. This is the semantic representation, entity staff, entity property for rent. We have to write two relationships, one from left to right, from staff to property is here, and from property to rent staff is here. So let's start with staff. We should start with A, or we should start with each. See here, this sentence is started with each, and this sentence is also started with each. Each is easier. Sometimes you can start with A. It is a little difficult, but it's correct. No problems. From staff, each staff member oversees property for rent. The relationship is oversees. Each staff member oversees a property. How many properties? We have to write the numbers. 0 or more. Some staff, they are working there, but so far they are not overseeing any property. So it can be 0 or it can be more. So each staff oversees a property for 0 or more properties for rent. Now start with property. Each property for rent is overseen by exactly 0 or more staff. Okay. Each property for rent is overseen by 0 or 1 staff member. So this is the semantic representation. We write these description. Then next step, in ER diagram, this is for our own understanding, okay? In ER diagram, we will represent the staff with a rectangle, property for rent with the rectangle. The relationship on the left side will go to right, and relationship of right side would go to left. So it's here. First entity is staff, second entity is property for rent. The description from the left, it will come to right. So it means each member of staff oversees 0 or more properties. So you see here 0 and more. Here it is written by star. You can also write it by M. It's okay. And the right hand side description, it will come to the left. And it says each property for rent is overseen by 0 or 1. So it is 0 or 1. So far the notation here which we are using is double dot. It means it is first value or it is the second value. Okay. Let's see a third example to understand it more. Two entities, newspaper, second property for rent. The relationship between newspaper and property for rent is advertises. A newspaper advertises a property for rent. Okay, so let's first write our relationship from newspaper to a property. And where do we start from? We start from A or each. Each is better, is easier. Let's do it with each. Each newspaper advertises how many properties for rent? 1 or more. 1 or more. Let's start from here. Each property for rent is advertised in 0 or more newspapers, because we do not give advertisement to every newspaper. Sometimes we give it to on 1 or 2, and some, of course, if they do not get that advertisement, it means 0 advertisement. So each property for rent is advertised in 0 or more newspapers. Where do we get these descriptions? We get it from our data requirements. You know, at the start we get all our data requirements, and we get this information from our data requirements. We do not think from our own brain. Everything is followed from the written data description, which is obtained by our database analyst. Okay, this was our semantic representation. In our ER diagram, the right side relationship will be written to the left, and left side relationship will be written to the right. This is our ER diagram. Entity newspaper, this is entity newspaper. Then entity property for ent, this is entity property for ent. The relationship it advertises, it should be in diamond. For simplicity, they have not made diamond, we must make diamond. Okay, then it is 0 or more, then it is 0, more, it is written in star, you can write star, you can write M. It is 1 or more, so it is 1, or more, you write it star. Okay, Alhamdulillah, we have seen 3 different examples. In the multiplicity, you saw that we had 2 numbers. We had rather 2 pairs. This is the first pair, and this is the second pair. This 1 dot dot 1 and 0 dot dot 1. These numbers are called multiplicity. Multiplicity has 2 parts. The first number, here the first number is 1, and then the first number in second pair, 0. This 1 and this 0, this is the first number in first pair, this is the first number in second pair. Together 1 and 0, they are called participation. And this second number in the first pair and second number in the second pair, it's called cardinality. Okay, so it has 2 things. First, cardinality. Second, participation. What is cardinality? Cardinality is the maximum number which is possible in the relationship. You see here, the maximum number here was 1 or more, so the maximum number, it can be any. Here 0 or more, so maximum number is many, m. So second number is our cardinality, and the first number, it tells us how many minimum number. How many minimum number, all or only some. So the minimum number here is 0 and minimum number here is 1. Okay, so we can write it in terms of cardinality and participation. This number 1 and this number 0, the first number I told you, these are called participation. Second number, cardinality. Cardinality tells us the maximum number, and participation tells us that are these only one instance or more. Instead of making it like we write here 1 dot dot 1 as participation or cardinality, it is much easier for us and better for us that we write it as an alternate notation in terms of minimum, comma, maximum, where the first number will always be considered the minimum value and the second number will always be considered as maximum value. So instead of writing 2 separate values, we will write them as an alternative notation of minimum and maximum. Okay. Okay. So some notations and their meanings. 0 dot dot 1, it means minimum, it was 0. Maximum, it is 1. 1 dot dot 1, it means exactly 1. It cannot be less than 1, it cannot be more than 1. 0 to many, it can be minimum 0. Maximum, it can be 1, 2, 3, 4, 5, any number. Similarly, 1 to many, here 5 and 10. Minimum is 5 and maximum, it can be 10. So it can be 5, 6, 7, 8, 9, 10. And the last one, interesting, 3 different values. Possible values are 0 or 3 or 6, 7, and 8. Okay. Summary of notations that we use so far. Simple rectangle, it is entity, regular entity. Double rectangle, it is weak entity. Relationship, we represent it with diamond. If this is a double diamond, it is weak relationship, and of course on one side it should be oval, it's an attribute. Do we have questions? Okay, if we have oval and attribute inside the oval is underlined, it means key attribute. If we have double oval, multi-valued attribute. If we have oval and it means some attribute, but there are other attributes which are describing this attribute, it means it's a composite attribute. If our oval is dotted, it means it's a derived attribute. This is not a part of our course, so we are not covering it here. Leave it for the time being. If there comes something, I will explain this to you. Okay, this was one notation that we saw using these symbols. It is one style, ER diagram. There is another style of making ER diagram that is called UML style. In UML style, we represent entities with the help of a rectangle, but inside the rectangle, we write down their all attributes. Instead of making ovals outside, we do not make oval outside. We make each entity is represented by a 3-compartment rectangle. So this is a rectangle. It has 3 compartments. The first is the name of entity. Second is the attributes. Third are basically, supposedly, it should be the methods to access these values, access these attributes, but for you, you can leave them empty. Okay, you don't have to write them when you are writing. Okay, so first entity, employee, their attributes. Third one, you can leave them empty. Second entity, department, these are the attributes of the department. Fourth, next is project, its attributes. Location, attributes, works on, attributes hours, manages, attributes, and then the start date. And this is the multiplicity. You can write it in terms of multiplicity, or you can write it in terms of maximum and minimum. I would suggest you that instead of writing multiplicity, you write maximum and minimum notation. The first number will be maximum, minimum, comma, second number maximum, and then it should be in the brackets. Some other notations, just for the sake of your looking, we cannot use so many different types of notations. Okay, you just see them and you note it that there are other notations also possible, but for us it is not possible to follow all of them. We will follow one of them for our practice. This slide is just for your knowledge that there are other possibilities as well, because there is no one standard that can be followed. Most widely used is one that we used in our course using these symbols. Second widely used is UML. Okay, here in this course we will follow the first style, this one. And UML, when you will actually learn UML in some other course, for example software engineering, for example your system analysis and design, then you can use this symbol inshallah over there. Okay, let's see a second example for today. The first example was our company database. Where was it? Company database. Yeah, this was our company database, ER diagram for our company database schema. We are going to see a second example for our university. This is a university database example. It has some description here, not the complete, but just try to look at it and please try to see if you understand this. You know the rectangles, these are entities, these are attributes, and these are the relationship, and these are the multiplicity written in terms of minimum and maximum. Can you please read each item of this figure and tell me if you understand it? Now we are going to do one exercise. So far we saw, alhamdulillah, several examples. Now we want to do something with our own hands, okay? So that we make sure that everything is clear to us. Study this. Please, all of you, read this carefully. Okay, hope you have read that. Our objective here is to draw an ER diagram from this description. You saw the description here, slide number 1. There is no data here. Then slide number 3, some description is here, and some description is slide number 4. The question is, draw an ER diagram. And you know that in drawing the ER diagram, what is our first step? Identifying entities. We have to identify entities. Okay, so read it again and identify entities. How do we identify entities? These are all nouns. Kullun asma, all nouns. They are either entities or attributes. For your help, since this is the first exercise, I have mentioned entities with green and their attributes as blue. Artist is an entity. Their attributes are names, birthplace, age, style of art. These are the attributes of artist. Second thing, another entity is artwork. And our second step is that we find their attributes also. Artist, year of make, title, and type of art. These are the attributes of artwork. Third entity, groups. And its attributes are kinds. Next page. Then group has more attributes, which is name. Another entity is customers, and it has attributes address, amount, name, artist, and groups. Okay, as a first step, we find that we have 4 entities: artist, artwork, groups, and customers. What is the next step? Find their attributes. So we have entities and we find their attributes. For your help, since it is the first example, first practice exercise, I have mentioned the attributes in blue. So you find attributes of each entity. Third step, what is the third step? Find their relationships. Okay, and from the description, from the given description, we find the relationship. These are the relationship between artwork and groups, customers and groups, customers and artists and artwork. Next step, make the ER diagram. So this is the ER diagram: artwork, attributes, group, attributes, customer, attributes, artist, attributes, and these are their relationship shown with the help of diamonds. And the next step was, actually all 3 steps are done. The next step is to mention their multiplicity. And since once again, it is the first example, so I didn't mention its multiplicity to make it simple for you. But interestingly, this description does not have any multiplicity. And since it does not have, we cannot make it from our own brain. Isn't there a way to connect them all? Actually, these relationship is the way to connect them. We have to find these relationship from the given description only. We do not make it from our own brain. This description tells us whatever the relations are there, we only take those relationships. If this description does not tell us any relationship, we do not make it. So we have seen that relationship can be between 2 entities, it can be between 3, it can be between 4. If the description tells us something like that, we will mention it.